This tutorial introduces the basic operations of Cadejo version 0.3. Cadejo is a MIDI management tool and suite of instruments for overtone. As a brief overview, MIDI messages are processed in a hierarchical tree structure, and at the highest level is an object called a scene, which responds to a single MIDI device. Each scene distributes incoming MIDI messages to appropriate channel objects. The channel objects in turn pass messages to performances. Though not technically correct, performances may be viewed as overtone instruments, and a channel object may transmit to any number of performances. On startup, Cadejo displays an initial splash frame. The overall layout of this frame is used throughout Cadejo. At the top is a toolbar with several icons. Below this is a large central area, and below this are information lines. At the lower left is the status area, in the center a progress bar, and to the right a path indicator. Clicking the toolbar skin button displays the skin dialog where the overall look of Cadejo may be changed. Changes made to this dialog are not permanent, and some pre-existing graphical elements may not be updated to match the new skin. The file cadejo.config may be used to set an initial skin. Most of the config values are self-explanatory, but two are related to the initial look of Cadejo. First is the initial skin value, which must be a string and must exactly match one of the available skins listed in the comment section above. The second value is the display bar style. The term display bar refers to a large alphanumeric text display used throughout the Cadejo interface, and there are 5 possibilities. First, if the display bar style value is nil, then the selected skin will provide a default style. The remaining possible values are keywords which override the skin defaults. The basic style uses a large native font and is the most efficient. The 16 style attempts to emulate a 16-segment LED display. The matrix style uses an active 5x7 matrix for display. It is flexible but is also the least efficient. Finally, there is the twilight style, which uses a set of icons to emulate a dot matrix. As the name suggests, this style uses the twilight color scheme and is more efficient than the matrix style. The twilight style may or may not be readable with non-twilight skins. Returning to the Cadejo frame, we see that the initial selected tab displays the server window. Select one of the displayed options and press the large Start Server button. If Cadejo detects a server is already running, this stage will be skipped. After the server starts, Cadejo switches to the MIDI device selection window, where a list of available MIDI devices appears on the left. It is important to note that the MIDI devices on offer are as the underlying Java JVM sees them. These are in no way related with MIDI devices available to the Jack server. If Jack, or another MIDI process, has a MIDI device open, an attempt to connect to it from Cadejo will fail. Once a device is selected, click the Create Scene button. After a moment, Cadejo switches to the Scene object and a new button appears on the toolbar. There are now 2 tabs in the central area, Tree and Scale Registry. The Tree tab is informational only and displays the current Cadejo process tree. Currently, no instruments are defined, so there is nothing to display. The Scale Registry tab is for the creation of tuning tables. The current implementation leaves much to be desired and is slated for replacement. It is operational, however, and basically a tuning table must be placed in the Scale Registry in order to be used. At the bottom of the scene window are buttons for the 16 MIDI channels. Clicking one of these will open a new frame for that channel. There is also a new parent button on the right side of the toolbar. This button may be used to navigate to the parent node, in this case the root scene. Returning to the channel frame, we see that it initially displays an Add Instrument tab. Clicking the MIDI button to the right, we see the current MIDI properties for this channel. Initially, these are set to inherit, which means the properties are being inherited from the parent node. The small text near each inherit checkbox indicates the inherited values. Looking at the bend panel, we see that it is inheriting a linear curve with a range of 200. Unchecking inherent allows us to override the inherited value. For bend, there are two values, curve and range. Clicking on the small pencil or edit button brings up a dialog where we may set a new bend range. Clicking the curve button advances through a set of possible response curves. Left and right clicks move the selection in opposite directions. Cadejo defines 22 response curves. The first 3 are constants. Setting a bend curve to a constant 0 effectively disables pitch bending. In the next column are the default linear curve and 3 exponential curves, which tend to emphasize large value changes to various degrees. The 3 convex curves do the opposite and tend to emphasize low value changes. The 2 S-curves respond as a combination of exponential and convex curves with a linear section in the middle. Finally, there are 8 inverted versions of the non-constant curves. Unchecking the remaining inherent checkboxes displays all of the channel's MIDI properties. Most of these are self-explanatory. You may scale the pressure curve and add a fixed bias value to it, transposes and semitones. The dB slider scales the amplitude of all instruments on this channel, assuming they do not override it. The dual-headed key range slider sets the MIDI keys over which this channel responds. Finally, there is the tuning table property. As with the scale registry, the tuning table option is a temporary implementation and will be updated in the future. Briefly, in order to use an alternate tuning, you must set tuning table value to exactly match an entry in the registered scale section of the scale registry. No harm will occur if the values do not exactly match. Cadejo will simply use the default 12-note scale. Returning to the Add Instrument tab, click on the large Masa icon to add an instance of the Masa organ. This will bring up an Add Instrument dialog. Near the top of this dialog are radio buttons for selecting the key mode. Not all instruments will implement all possible key modes, but we see that Masa has 3, exclusive, mono, and poly. The exclusive mode is a limited mono mode where only the first key down produces a note. Subsequent keys have no effect until all the keys are released. This mode is intended to provide alternate articulation on the first key press on a legato passage. Below the key mode are options to set the supercollider output bus and the polyphonic voice count. The voice count defaults to 8 and is enabled only if the poly key mode is selected. In the center of the dialog are several lines where MIDI continuous controllers may be assigned. Each instrument will have its own set of controllers. Near the bottom of the dialog is a text field for entering the ID for the new instrument instance. An instance may have any ID so long as it is unique. Cadejo will automatically provide a unique ID for each created instrument. A moment after clicking the Add Instrument button, a new icon appears at the bottom of the channel frame. If we now use the Parent button to view the scene frame, we see 2 changes. First, the Tree tab now contains information about the current Cadejo process tree. Secondly, there is now an asterisk next to the channel number. This asterisk indicates that at least one instrument is active on the channel. Returning to the channel frame and clicking the small Masa button displays a new performance frame, which initially displays the program bank. The Performance MIDI button contains the exact same information as with the Channel MIDI button, except now it is at the performance level. Clicking the MIDI CTRL button displays a similar page for mapping MIDI continuous controllers. Finally, the Edit button displays the program editor. Note that the editor is not created prior to its use. The first time the editor button is selected, there may be several seconds delay while the editor is being created. Subsequent clicks on the editor button will be more responsive. The buttons on the left of the editor are for initializing the current program, creating a random program, open, copy, paste, and save individual programs. Individual program files have extensions matching the instrument name. Each instrument type will define its own set of editor-specific buttons. Masa is a relatively simple instrument and adds only a few editor tabs. This is an overview of Cadejo and not a tutorial on Masa, so we will skip Masa details and concentrate only on the common elements. If any changes are made to the current program, the word Modified appears above the large name display near the bottom of the frame. This indicates that there are unsaved changes. This notification runs on a low priority thread It may take several seconds to appear. The components to the lower left side are used to save the current data into the program bank. The number indicates the slot where the program is to be stored. The up and down buttons change the slot number in either steps of 1 or 8. Clicking the Store button actually stores the program. Once a program has been stored, the word modified is extinguished. Again, this may take a few seconds as the thread catches up to reality. The only items remaining are the bank control buttons on the lower right side. Init, open, and save do what you expect. The file extensions for bank data is the instrument name, an underscore, and the word bank. The undo and redo buttons apply only to changes in the bank and not to individual edit changes. This concludes the initial Cadejo tutorial. Thank you.